Hi, my name is Alan Hong, Strategic Marketing Manager at Terasic Technologies. Today, in an FPGA design world where bigger is better, it's really hard to find a small and portable development kit. Well, today I'm very excited to present to you our latest product, introducing the DE0 Nano. Ideal for developing embedded soft processors, this beautiful miniature device measures only 49mm by 75mm and weighs only around 40 grams. That's smaller than most cell phones. But make no mistake, small does not equate to less. We've packed the latest low-power Altera Cyclone 4 FPGA into this thing, with 22,000 logic elements to work with. But we're just getting started. The DE0 Nano also features two separate extension headers, which means 72 free I/O pins. A third header also supports an analog to digital conversion, with 8 ADC channels and 16 free I/O pins. Also featured on the board is a 3-axis accelerometer for even more sensing applications. The acrylic covering on the entire board ensures that this dev kit can withstand even the most rugged of treatment. It's the entire FPGA development lab, all packed into one tiny aesthetic package. So let's get started by introducing these features. So now let's first connect our FPGA dev kit to our host PC. Now that it's connected, we can see that the FPGA dev kit automatically turns on. So now we'll open up our folder to open our DE0 Nano control panel, which is a GUI that lets us automatically verify all of our hardware components very easily. On the left-hand side, we can see that we have a list of our hardware components. First, we'll test out our green user LEDs. So now I'll click Light All, and as you can see, the DE Nano lights all of the green LEDs. I can also choose Unlight All, or selectively choose which LEDs I would like to light up. Next, we'll go to our Switches tab, and we can see we have a GUI representation of our dip switch and buttons. And now I'll flip down the dip switches, and we can see that the GUI responds accordingly. I can also press on our push buttons. So if I push down on button 1, we can see that the key is depressed on the GUI as well. Next, we'll test out our memory. For memory, we have a list of 3 to choose from: the SDRAM, EEPROM, and EPCS. We'll just be testing the SDRAM for now. So we'll go over there and type in a 12 value for write at address 0, and we'll go over to read, and we get the same value back. Next up, we have our accelerometer, where it shows we have 3 coordinates, the X, Y, and Z coordinates. As you can see, as I pick up the DE Nano and tilt it to the right or to the left, our X, Y, Z values change accordingly. And lastly, we have our ADC tab, which monitors the voltage levels on all of our 8 different channels. So now you can see that the control panel software is a very easy way for you to verify your hardware components. So moving on, I'm really excited to share with you our product demonstrations, which truly showcases the device's capabilities. Keep in mind that the following demonstration source files are all included in the product CD-ROM, letting you get started with your design as fast as possible. So our first demonstration is our DE0 Nano breathing LEDs. We have a simple PWM driving our green LEDs. We have 2 sets, and we can also change the speed of our PWM by flipping a switch. And you can notice that the 2 sets are flashing slower. We can also flip the second switch, and the speed decreases even more. Next, we'll demonstrate our simple ADC demonstration. If we flip over our DE0 Nano, we can see on the 26-pin header, we have a variable resistor with the orange wire connecting to our VCC 3.3 volts. Our blue wire is connected to our ground, and our yellow wire is connected to our channel 0 of the ADC. So now we can see that through the dip switch, we have selected 0, and we can start the demonstration by pressing our key 1. So now, as I turn the variable resistor, we can see that the corresponding value is shown on our green LEDs. As I decrease the voltage, less LEDs light up. It effectively translates our analog signal into our digital signal. Third, we have our accelerometer demonstration. And you can see as the board is level, there's 2 LEDs that are lit up in front. But as I lift it, we can see that the LEDs float to the top. And I'll tilt it in the other direction. We can also generate an interrupt by tapping the DE0 Nano. Our last demonstration really showcases the versatility of the DE0 Nano. We have our camera module right here, which is a 5 megapixel CMOS sensor, and we also have a 4.3 touchscreen, both of which are even bigger than our DE0 Nano. So we'll attach both of these to our DE0 Nano, and the camera is going to serve as the input and it's going to show it on our external touch panel module. And so now I'll program the device, and now we can see that the thoracic cup is now on our LCD. I hope that these reference designs have truly highlighted the enormous capabilities of the DE0 Nano. With its small size, high density FPGA, low power consumption, and extensive interfaces, the possibilities are only limited by imagination. As I mentioned before, all of the reference designs are available on our DE0 Nano CD-ROM, ensuring that you have enough resources to get started as quickly and simply as possible. If you have any further questions, you can contact our international support team at support@thoracic.com. For more information on the DE0 Nano, please visit our website right now at www.thoracic.com. Thank you for watching.